Kakti, ladies and gentlemen, welcome to another series of tutorials with me, Aubrey Sigodnia. We are looking at a very interesting question from Pure and Applied. This is a combination of mensuration and calculus. All right, so if you haven't already, please subscribe to the channel, leave a like, comment, and share the lesson. All right, so the question reads, from a rectangular piece of thin cardboard, which is 16 by 10, the shaded areas, which are these areas of length x centimeters, are removed. So this part is removed and that area is removed, as shown in the figure below. Then what remains, which is the white part here, is folded into a tray. All right, the first question asks us to find the volume, or to show that the volume is equals to that. All right, so that is the first question that we're going to tackle. Then we'll go to the next question here. So let's just explain, or let's try to interpret the question on this. So this part has been cut. So these are the parts that have been cut. So this part has been cut and that part has been cut. Okay, and we are only remaining with the white part that is there. All right, so now what will be the base of this tray? So the base of this tray will be this part that is here. So that will be the base of this tray. So that will make the base of the tray. So now if I were to draw that very quickly, and let me just move it a bit this side. All right, so the base of the tray, so the base of the tray like that. Okay, so so that will be the base, which is this part of this tray. Then we have this part that have been cut, that are forming the sides of the cardboard. So this part will form the side of the cardboard on the left here. So we'll just do that. So that is the side of the cardboard on that end there. Then the other side of the cardboard is this part here, okay, which is there like that. Okay, so that is the other part. Then the sides will be this side, right? So this is that side and the other part is that side there, so which is over there, and that is the tray that is formed here. Now when you look at this tray that we have, these parts that were cut, they are these parts that are making the sides here. Okay, so this corner here, if I were to shade it, is making this corner here, which is of length x. So that is x centimeters right there. All right, so we have that. Okay, and that is the base of the tray. Now to find the volume, we know by default that volume of any solid is the base area times its height. Okay, that is the volume for any solid. That is the base area times its height. So for us, what we have here, the base area will be the area of this bottom part here. Then the height will be our x there. So what is the base area of this bottom part here? All right, so we just need to look at this that we have here. So this is a rectangle. And how you find area of a rectangle, area is just equals to the length, which is the long side, times the breadth, which is the short side. So what we just need is to find the length and the breadth. Now to find the length, we've been told that this entire length, or let me say this line from here to here, is 16 centimeters. All right, and if this line is 16 centimeters from here to there, let me use purple. So if from here to there, that is 16 centimeters, and this part was removed, and that part was removed, and it so happens that this part is x and that part is x. Now what we need is this part. So how can we find this part? Well, to find this part, we just say this is 16 minus this part, which is x, and minus this part, which is x minus x. For the same thing for the breadth, this entire part is 10 centimeters. So now if this entire part is 10 centimeters, and it so happens that this part, which is x, is removed, and that part, which is x, is removed, what are we going to remain with? That will be 10 minus x minus x, okay, which is just 10 minus 2x, and this other part is 16 minus 2x. Right, so now we have our two lengths. So our area will finally be equal to the breadth. Our breadth will be, our length will be 16 minus 2x. So that is 16 minus 2x. Then our breadth will be 10 minus 2x. 10 minus 2x. And that will be the base area that we need right here. So now finally, volume will be equal to our base area. We get this, so we put that in brackets. So that will be 16 minus 2x times 10 minus 2x. 10 minus 2x, we enclose that, then times the height, which is x there. The height of this solid is x there. All right, now we just start simplifying and we will get to this. All right, so simplifying, our volume will be equal to, we start with this that is inside here. So we say 16 times 10, that will be 160. 16 times negative 2x, that will be negative 32x. Then negative 2x times 10, that will be negative 20x. Then negative 2x times negative 2x, that will be positive 4x squared. Okay, and everything here is being multiplied by, let me write this properly. That is 160. 160, then everything is being multiplied by x like that. So we can distribute the x. So that will be volume being equal to, so x times this, that will be 4x to the power 3. Then x times negative 20, that will be negative 20 x squared. Then x times 32, that will be negative 32 x squared. Then x times 160, that will be plus 160x. Okay, having that done, we can say we can factor out of 4 from here, because look at this, we need to factor out 4 from this so that we get something similar to this. So we need to factor out 4. So when we factor out 4, for us not to change the question, it means that we are dividing everything by 4. So this is something as x to the power 3 divided by 4, then minus 20 divided by 4 x squared, minus 32 x squared divided by 4, plus 160 x divided by 4. So this is what we mean when we are just factoring out. That number that we're factoring out, we're dividing throughout. Yeah, so that we don't change a thing, because look at this. So when we say 4 times this, the 4 and the 4 down there will simplify. 4 times that, the 4 and the 4 there. So that is the main idea on factorizing, right? So simplifying this, there will be 4, then this simplifies to 1. So that will be x to the power 3 minus 4 into 20, that will be negative 5 x to the power 2. Then 4 into 32, that will be 8 x squared. Then 4 into that, that will be plus 40x. Okay, so we now simplify. Our volume will finally be equal to 4. Inside here, that will be x to the power 3. We add this and this, that will be negative 13x squared plus 40x. So this is our volume. Hence, we've shown that the volume is equals to that. So that is the first part of the question. All right, now the second part of the question is asking us to find the possible value of x which will give the maximum value. All right, so now we're looking at maximums. Now what you should know is that at the maximum, the gradient of any curve is equal to 0. So at the maximum, the gradient is equal to 0. In other words, dy dx is equal to 0 at the maximum. So for us to find the maximum value of x, we just find dv with respect to x, then we equate that to 0. So dv dx, we differentiate this with respect to x. What we're going to get is, so this is the second part. So what that will be the 4 out here. I'm assuming you already know how to differentiate. So this would be 3x to the power 2 minus, that would be 26x plus 40, like that. So that is the derivative of this. So now we said at the maximum this will be equal to 0. Actually, both at the maximum and at the minimum, the derivatives are equal to 0. So basically 4 open brackets 3x squared minus 26x plus 40 should be equal to 0, because at the maximum that is equal to 0. So we see that we can divide throughout by 4, and what we're going to remain with is 3x squared minus 26x plus 40. So sorry, this is 40 plus 40 should be equal to 0. So by dividing throughout by 1 over 4, or by multiplying throughout by 1 over 4, that is what we're going to get. And what we have here is this is a quadratic expression. All right, so this is a quadratic expression. We just solve for x. So x will be equals to negative b plus or minus root of b squared minus 4ac all over 2a. So in this case, this is our a. So that is our a, the coefficient of x squared. That is our b, and that is our c. Okay, so meaning that x will finally be equal to our b, that will be negative b, which is negative 26, plus or minus root of negative 26, then everything squared, minus 4 times a is 3, and c is 40. Then everything divided by 2 times a is 3. So now when you simplify this, you're going to get two values of x. X is equals to 2, or x is equals to, should be 6.67. So these are the two values of x that you find. Now, which one will give you the maximum volume? So for one that will give you the maximum volume, though it's obvious that this one will give you the maximum volume, you get the volume equation, which is v, which is 4, what was that? That is 4, open brackets, x to the power 3 minus 13x z plus 40x. Okay, so we get the volume formula, which is here. Okay, so that is 13x squared, like that. So we plug in these values and we see which one will give us the maximum volume, and that is the maximum value of x that gives us the maximum volume. So obviously it will be this one, but you have to be careful. If this was negative, then it would most likely be the other one, but you have to be very careful on that one. So that is about it. So you try out which one will give you the maximum volume, and that will be your maximum volume. So have a good evening. If you have any question, leave them in the comment box. Good night.